name is Sydney Jackson. I'm a first year pre-pharmacy major from Chicago, Illinois, and today I will be showing you lesson 4.4, curve sketching techniques. Okay, there are three objectives. The first objective is modifying the graphing strategy. Second one is using the graphing strategy, and third one is modeling average cost. Okay, for graphing strategy, step one is analyze f of x. You find the domain, the x and y intercepts, and the asymptotes. For step two, you analyze f prime of x. Here you find the partition and critical numbers. You do the sign chart. You find out where f of x increases and decreases, and you find the local min slash max. For step three, you analyze f double prime of x. You also find partition and critical numbers. You do the sign chart, you find the intervals where the graph is concave up and concave down, and you find the inflection points. And step four is to sketch the graph where you draw the asymptotes, intercepts, local min and max, points of inflection, and you plot additional points as needed. Okay, so the problem that we're gonna do today is f of x equals 5x times natural log of e to the negative 0.2x. Okay, so the domain is negative infinity to positive infinity. This also means that we don't have a vertical asymptote. So the next step is to find the x-intercept, and we do this by setting this problem equal to 0. So we're gonna do that here. Okay, so natural log of e can never be 0. So we're just gonna go right here and go to 5x equals 0. So we do 5x equals 0. So the x-intercept is 0, 0. So next is the y-intercept. And to find the y-intercept, you make x equal to 0. So we do 5, plug in 0, e to the 0.2 times 0, and this is going to equal 0 as well. So the y-intercept is also 0, 0. So next, we're going to find the asymptotes. So we already established that there are no vertical asymptotes because the domain is negative infinity to infinity. But we have a horizontal asymptote. So to find the horizontal asymptote, we take the limit of 5x e negative 0.2x as x approaches infinity. So this equals limit 5x as x approaches infinity times the limit of e to the negative 0.2x as x approaches infinity. So then this equals infinity times 0, which is equal to 0. So that means that there is a horizontal asymptote at y equals 0. Okay, for step two, we're going to analyze f prime of x. So f prime of x is equal to, we have to use the chain rule. So 5x times the derivative of e to the negative 0.2x plus e to the negative 0.2x times the derivative of 5x. So this equals 5x, we just carry that down, and then the derivative of e to the negative 0.2x is you bring down the negative 0.2 times e to the negative 0.2x plus e to the negative 0.2x, and the derivative of 5x is just 5. So then this turns into 5 times negative 0.2 is equal to negative 1. So it's negative 1x times e to the negative 0.2x plus 5 e to the negative 0.2x. So this, then you can take out like terms, which is the e to the negative 0.2x, negative 0.2. So then that just becomes 5 minus 1x. Next, we are going to use the sign chart. So, well, first, I lied. We're going to go to find the critical values. So like I said earlier in the video, this can never be 0. So we're just going to use this right here. So 5 minus, let's just say minus x because that's the same thing, equals 0. So take negative 5, bring this up here. That equals negative x is equal to negative 5. 1, x is equal to 5, which is our critical value. Now we can go to the sign chart. I'm gonna make that up here. Okay, so this is where we're gonna find where the graph increases and where it decreases. So we can pick a number less than 5. So I'm just gonna pick 0. That's the easiest one. To the right, I'll pick 7. So did the calculations, plug, oh, forgot something. So once you plug this into f prime of x, you get a positive number, which means it's increasing from negative infinity to 5. And then once you plug in 7 to f prime of x, which is right here, this is f prime of x, you get a negative number, which means it is decreasing from 5 to infinity. Okay, so since it is increasing right here and decreasing right here, the graph should look something like this, which means it has a local maximum. So there is a local maximum at x equals 5. So to find the local maximum, let's erase some of this. Okay, so now that we've cleaned the board off, here from negative infinity to 5, it is increasing. From 5 to infinity, it is decreasing. There is a local maximum at x equals 5. In order to find the point, the y, we have to plug 5 into the original equation. So once you plug 5 into the original equation, you get 9.2. So the local max is 5